The next optimization technique in Stratton's taxonomy is called privatization. So where tiling exploited the fact that multiple threads are reading from the same memory locations, thread sharing input is good, privatization helps avoid having multiple threads write to the same output locations. So privatization takes some output data shared by multiple threads and duplicates it so that different parallel threads can operate on their own private copy. The private copies are eventually merged together to recreate the result that would have been produced in the shared data used by all the threads before privatization. So histogram makes a good example. As you've learned from our previous discussions and problem sets on histogram, there's a bunch of ways that you can approach the problem. In particular, you could program the kernel to have each thread keep its own local histogram as it looked at a bunch of pixels, and then use atomics or a global reduce operation to combine the buckets from the histograms from all the threads into one set of shared results. You can also apply this idea hierarchically. For example, you can have each thread block compute a combined histogram in shared memory, and then have other thread blocks do the same, and then accumulate the results into a single global histogram. So in this example, we would have per thread privatized histograms and per block privatized histograms. Now in practice, the GPU has so many threads that you don't want each one to have a huge private data structure. So this approach might work well for a small histogram, say 5 or 10 buckets, but you would probably skip the per thread privatized copies for a histogram with hundreds of buckets and just do the local version per block.